I'm reusing a fictitious character named Maria. She's one of our data hero last year. She owns reference data for the enterprise. She was able to take advantage of the Snowflake data sharing capabilities to provide data to her consumers, right? So, and then towards the end of my presentation last year, I did mention Apache Iceberg as one of the possible solutions, and that's what we're going to talk about here. So who is this Maria? So like I said, she's in our she's a technologist in our front office investments team. She heads up the financial market data and product data platform. Her platform manages several data domains. For example, she owns the security or financial instrument data, such as equity, fixed income, bonds. And these security data, they always come with pricing data. So this way you could evaluate the positions that you hold in those security. Issuer data, those are the companies that issue these instruments. They often come with legal entity data and some ratings. Index data and benchmark data, that's quite important for an investment management company such as T. Rowe Price, because that's what we use to actually manage our benchmarks, our portfolio against these indices, right? So, sorry. And then Maria has actually several consumers of her data. She works with them to ensure that the data that they receive meet their requirements, and of course, they're known quality. Maria and her team also, they work through issues, right, when her consumers report those issues in. She and her team provide some level of service level agreement to ensure that the consumers understand and have the proper expectations for their data. So how many Marias do we have in the audience? Or somebody who plays the role of Maria? No? Don't be shy. You don't have to be in finance. It works in other industry as well. The reason why I ask is one of my colleagues who attended last year, he was the actual person who Maria was based on. So, but he's not here this year, so you don't get to meet the real person. So Maria has these use cases. So I did mention that that she has these reference data for security and product. But I've narrowed down the domains into these three domains: the legal entity data, again, which becomes an issuer data once the company issues an equity or bond; the financial instrument themselves, again, it comes in the form of equity or fixed income; index data are the top level index information, and then they have constituents, which are actually the security data as well. And then we'll focus on Maria's consumers. So John, for example, he's part of the quant team in the front office investment organization. He creates mathematical models and algorithm in order to pick the right investments and generate the alpha. If you don't know what alpha is, it's the measure of return against an index. That's why it's so important for us to have the right indices data. Jane is a member of the portfolio analyst team. She assists the portfolio managers. They gather data using spreadsheets and whatnot from multiple sources, prepare the data, improve the quality where they can before providing them to the portfolio managers. The portfolio managers then, of course, make the right decisions in terms of investment positions and whatnot, right? So Jen is another user. Oh, well, she's actually not a user. She's a product owner within Maria's team. She's responsible for producing reusable data products based on requirements from multiple consumers who access them across the organization. So now that we understand what data Maria offers and the different roles of our consumers, let's try to understand her challenges, right? So Maria's data come from different sources. Some of them are for external data providers, some are from internal within the firm. The data can also come in many different formats, and they can use different technology, for example, APIs, files, messaging, etc. Maria would like to provide her data to her consumers just once and avoid duplicating the data. She'll also need to make sure that her consumers, once they consume the data, that they don't propagate it, which could then, in turn, of course, create more duplication, right? So And then, of course, our consumers, they would want to stay in the technology of their choice, right? It's very hard to get people to migrate to a new technology based on the platform. And that usually becomes a kind of like a barrier of adoption for her services because of cost and other sometimes political view as well, to be honest. So, and lastly, everyone has limited resources. And there's still expectations for data governance and controls to be in place to make sure that they protect the data. So what are Maria's options? I've limited her options into 3. We'll get into the details of each of these in a minute. But at the highest level, traditional solution involves legacy way of processing data. I think everybody understands what that is. Snowflake solution is a bit more modern, but it's still limited in scope when it comes to sharing the data itself, right? So, and I'll talk about that in a minute. Finally, Apache Iceberg, which is what I believe to be a really good solution for Maria to help her with her challenges, because otherwise I won't be here presenting to you all. So let's get started. So here's the traditional solution architecture. Here we can see Maria sources data from Snowflake shares, as well as other data feeds. Some of these data feeds are shared through shareable objects, or they're sent via secure file transfer. I was actually just at the CDO session, and the CDO Snowflake said, hey, can we all get rid of secure file transfer? So that was funny. For the data that are sent as files, of course, they have to perform minor transformation and validation before loading them into the database. So it then has multiple processes, of course, to extract the data out with different data domains to produce their shareable files so that her consumers can use it, right? So that's good because they are based on a common data model, but it does create duplication, as you can see, right? So there's a database, there's a file, and then once our consumers actually use it, and that's what's happening, right? So John is actually just loading the data that was extracted by Maria into his stage, then process it before loading it into the final database. Jane, on the other hand, simply uses the advanced modern data pipeline to kind of like process the data and store it into a bucket. She doesn't need a database because she's pretty savvy with like that, right? So Jen uses replication or Jane's data capture, and then she creates views on top of it. So there's really not a lot of transformation there. So the traditional solution, of course, enables Maria to provide her data to her consumers. That was easy, right? But we've been doing that for the last few decades. At least I have. I've been in the industry for a while. So, but Maria still has challenges. So Maria has no control over who gets access to the data once the data is copied out of her platform into her consumer's platform. She will need to trust her consumers that they'll actually do the right thing and propagate the data governance and security controls all the way to the copy of the data. Maria's consumers can process the data differently. This is a big one. There's no guarantee that the consumers will apply the consistent logic in terms of processing the data. For example, transformation logic could be different, and that creates inconsistency on the data, which becomes Maria's problem because the consumers of the downstream data complains that they're not the same, so therefore she has to solve for it. That's not really her problem, it's actually the consumers. So anyway, let's jump into the Snowflake solution. So you can take a picture of this, it's a little bit newer. With the advancement of the Snowflake's data sharing, Maria can use private data exchange or private listing as a way to share her data with consumers who are using Snowflake as well. This enables her to manage the access control for her data. And also she can track the use, how the consumers are actually using her data, right? So she gets metrics around that. Unfortunately, she doesn't have a way to share data outside of file extract to anyone else who's not on Snowflake. Now that's a disclaimer, there's many ways to do that, but that's out of scope of my talk today. Otherwise it wouldn't be an Apache Iceberg talk. So, oops. All right, so here we can see that Maria still has the same ingestion process, so that doesn't really change. What has changed is the private data exchange or private listing, as I mentioned. Both John and Jen can actually just request the access to share. Once that share is approved, or that request is approved, the share is established, and then they can go on and use the data. For the most part, Jan and Jen can still copy the data, but of course, then it's a little bit easier to manage that and set the contracts. Jane's data access still is the same. Why? Because she's not in Snowflake, right? As I mentioned. So some challenges. Maria's able to use the data sharing to scale her solutions to manage consumers. That was a big part of my presentation last year, is being able to share to more consumers. It provides her with self-service subscription, automated provisioning if you're using private listing. PDE, you still have to do manual process, but it works just as well. So how many people have seen private listing or use private listing or PDE? All right, so now we get into the Apache Iceberg solution. But before I talk about the solution itself, let me go through what Apache Iceberg is. So Apache Iceberg is an open source table format. The data in that table format is then stored on object stores like S3 buckets. So it's not the S3 bucket, it's just the format. It provides SQL access, right? So SQL access to the data that's on the bucket, provided, of course, that the SQL engine complies to the Apache Iceberg standards. They also provide libraries that you can use to read the Apache Iceberg table directly using APIs such as the S3IO API. And you'll see that in a minute during my demo. What it's not a SQL engine. So Snowflake is the SQL engine, Apache Iceberg is not. Snowflake conforms and complies to the standards of Apache Iceberg. That's why they can read the tables. It's not a compute engine or processing engine, or it's not a data pipeline. As I mentioned before, it's not a storage. Again, the storage is S3. And it's also not a service. So again, here's some of the features that I mentioned already. So it supports SQL, including DDL, DML. It has the ability to insert, update, delete data. It supports schema evolution. If you've ever used that with Snowflake, they do the same thing. Partitions data without the user having to specify it. That's actually a big deal. You don't necessarily have to configure the sizing of your partitions. It provides time travel access to your data, and then you can roll back to a certain snapshot. And if done properly, I've never done this, but if done properly, it does data compaction as well. So here's the Iceberg table architecture. Just a disclaimer, this is not my diagram. I stole this from the internet. We're not being recorded, right? The architecture are composed of three major components. The Iceberg catalog itself, that's the one that tracks the database, schema, table definition. In this presentation, I actually did use AWS Glue Catalog and Snowflake Catalog as the Apache Iceberg catalogs. And then the announcement today, they have that unified catalog. That's actually pretty exciting. And I'll talk about that in a minute. The second component is the Iceberg metadata. So that component has the information about how the data is actually stored. It's comprised of the metadata file that you see there. No, this doesn't work. And then the metadata file. The metadata file actually, it creates a new copy or a new version of it every time that the data is actually updated. So you can see the snapshot is actually copied over to the next metadata file. And then, of course, the metadata file points to the manifest list, which then in turn point to the data files themselves. The table on the right, not the table, but the grid on the right, actually shows some of the technologies that I've tested. Anything that's in red, it's actually available, but I wasn't able to test it. And a huge disclaimer, because when I was writing this, they always tell me, make sure that you say the disclaimer. This testing that I did was before the Iceberg private preview before this summit. Okay, so any Snowflake people, you're happy now, right? So, okay, so what's the Apache Iceberg solution? Note that I did this on AWS, so take it with a grain of salt, right? So I'll walk through this step by step because it's a bit complicated. But let's start with the storage. So this is your typical data lake architecture. Here we can see the ingestion bucket is an S3 with the raw data. And the data is curated and put into the curated bucket. Then the data is the data in the curated bucket is organized by data domain. For example, the legal entity, financial instruments that I mentioned earlier. And oftentimes the data in that stage, in that curated layer, utilizes a well-defined data model. It's essentially your warehouse, right? So it's the new version of the warehouse or the data lake. And then the distribution bucket is the bucket that's used for the data products. So that's how the data products are what our consumers would use, right? So next you have the data processing and data pipeline engines. Data is read in from the ingestion bucket. This is using direct S3 API or JDBC, depending on how you're doing it. In Maria's use case, some of the landed files are pretty structured, so she was able to actually create a Apache Iceberg table format out of it, and then people can read it using SQL. For the files that are a bit more complicated and you can't simply transform it, she has to use the S3 API. And then, as I mentioned, Apache Iceberg is optional in the ingestion stage, but they are actually required on the curation and the distribution stage. Because on the ingestion side, you want to preserve the raw data as much as possible, right? So that's something that I would recommend. All right, so you'll notice that there's two catalogs that I mentioned, Snowflake catalog and AWS Glue catalog. That's because I wanted to be able to share data between those two platforms, right? And when you create the Apache Iceberg tables, unfortunately, you have to actually use one of these and you have to decide on which one, right? So we do need a combined data catalog. I think, again, the keynote said it's unified data catalog, but this will help unify the Glue catalog and the Snowflake catalog and simplify access for the consumers, right? So Maria would not want her consumers to go to two different catalogs to search for the data. The shared catalog also does additional data governance capabilities, such as data contracts, data classification, lineage, and other data governance functions, right? So all of which are important for enabling the proper use and provenance of the data. And then, of course, the data processing pipeline can read the curated to produce the distribution layer or the distributed products. Now, the Apache Iceberg tables can be accessed with a variety of SQL engines. What you'll see on the diagram, the SQL engines are grouped into two categories. That's because Snowflake owns the account, the AWS account, right? So we own our account. So whenever you have to do this, you have to enable cross account sharing between Snowflake and your AWS. So it's not unlike the external table capability, right? So this doesn't mean that the other engines do not need cross account. It's just that when I was testing this, the configuration was on my shared AWS account, right? So, and finally, the metadata catalog can also, because it has the governance capability in it, it helps to secure access to the data using external policy engines. Those policy engines can then be pushed down to the SQL engines for enforcement. Now, the caveat here is not every SQL engine has implemented this yet, right? So Snowflake has, if you're using Immuta, for example. Is there any Immuta representative here? Because they could talk about that more. So if Maria implements the Apache Iceberg solution, she's able to reduce data duplication by enabling access to the Apache Iceberg from any SQL engine without moving the data. Access control can be managed externally and enforced by those SQL engines, as I mentioned. Again, this is not really part of Apache Iceberg, but I heard Ryan Blue is actually working on this. Data is organized by data domain, which makes it easy to find and understand the data. Solution, however, still relies on heavy data governance, any possibility of automating data governance, of course, and change management would help. So now I just walk you through the data lake architecture, which utilizes the Apache Iceberg table format. And it enables it using multiple SQL engines, right? So now that is actually good enough for most part, but it's part of a bigger picture, at least for Maria. So let's start with the ingestion capabilities of the architecture. Looking at the diagram, you can see that there are various data providers who can utilize various techniques for providing the data. their queue notifications, event messaging, API for pull requests, manage file transfers, even though we're trying to get rid of that, and legacy bridge. So this way we can actually still continue to support the legacy platforms. And finally, a little bit more modern capabilities such as data sharing, like Snowflake has, right? So, and then once the data is sourced, we of course use the data pipeline components to process the data. There are several patterns that I'm not going to go through. And again, the data sharing, it just goes directly to the data lake. Now, not all data comes from external or internal data providers. Some data are actually, they're generated by your operational or transactional business processes. And these data can also be captured by the data pipeline and pushed down to the data lake. There are use cases where you don't want to persist that transactional data, for example, down in the lake. For example, for real-time access, you may want to use like a virtualization layer to make it a bit more real-time, right? So here's a concept of the data mesh. So we're introducing a data mesh partly because Maria wanted to have a federated model for managing data products. And it also enables, as I mentioned, kind of like a federated query across the data lake and operational transaction applications. But again, in Maria's use case, she does want to land as much data onto the lake because she wants to provide like an unbroken history. That's a new term in our organization, actually, that we're going after now. It's unbroken history of our data, which is not as easy as it sounds. Now, getting back to the data mesh concepts, the data needs to be provided to the consumers as data products. That's one of the principles of data mesh. They have to be organized by domains, and they must have associated data contracts or service level agreements. The virtualization engine that you can see down there can be used to connect the data from the operational storage to the data. Data sharing is still available, so that's something that Maria still promotes. Consumers, whether they're applications, business intelligence, direct users, can now discover the data products through the catalog and request it. Once the requests are approved, they can access the data using either SQL or API. So that's actually a big deal. All of these capabilities are governed by the data services provided by the platform, which then can federate the accountability, as I mentioned before, because we want to use the same data governance framework for everybody to have, so that everybody can manage their data products accordingly, right? So, and as you can see, the data governance function, as I mentioned before, are like metadata management, data product management, security, protection, entitlements, and so on and so forth, and observability. So that's a big deal. All right, so let's step back a couple of minutes, dig deeper to Maria's use case. Here we can see that she has multiple data sources on the left. She needs to take these raw data sets and then transform them into a mastered curated data in the middle, and then project the data onto the right side, which then is the data products, right? So, and if we follow specifically for the legal entity or company data, she will need to match the company and the legal entity data together using some keys. That's what's called mastering. And then she links the other data sets like security to the issuer, for example. And then the security has pricing again. So you actually have to make those linkages as well. And then finally, the consumers are provided different projections. Again, that's another word that we're using, data projections, because somebody might want to see the start of day view of the data. Somebody might want to see the intraday or end of day, right? So there's a bit of a difference in that thing. So the other thing that you should note are the legends at the bottom. Some of them are stored in S3. Some of them are stored in Snowflake. For anything that's on S3, it can be accessed by Athena or Spark. So this is essentially what gives the platform the Polyglot capabilities. Now, if we overlay Maria's use case on this, here's the ingestion part. As you can see, the multiple data sources without any linkages. She can use the pipeline services and the ingestion storage to actually master the data and put the data in the curated layer. And then Jen can actually then start using the data mesh architecture to pull the data from the curated layer and then produce these different projections of the data products, right? So, and then finally, you have Jane and Jen kind of like consuming the data with the appropriate SLAs that Jen had established. So here's where we get a little bit technical. It's a simple implementation of these Apache Iceberg Snowflake components of the architecture. This should provide you with some insights in how the Polyglot platform can be implemented. Again, disclaimer, everything that I tested here is using the private preview version of Snowflake's Apache Iceberg prior to this summit. So let's walk through left to right. So for the legal entity, I used the AWS Glue catalog that you see in the middle to create the tables using Spark and put it into the S3 bucket that's right in the middle, the middle on the left, and then the middle of the middle. And then I can access it through Athena at the Trino and Athena at the bottom, right? So just using the same Glue catalog. And then finally, I imported the same Apache Iceberg table into the Snowflake catalog, and then I can query that same table on the Snowflake side. Notice the arrows. I can read and write when I'm in AWS because I'm on the AWS catalog. When I brought the table into Snowflake, I can only read. So now, Spark on the Snowflake side, using the Snowflake catalog, trying to read that table, that's the Apache Iceberg, which was created in AWS. That doesn't work. There's some limitations in the way that Snowflake had actually implemented it, right? So I don't know when they're going to fix it. So now going right to left, so we focus on the security data on the right-hand side with the financial instrument. I created the table into Snowflake, into the Snowflake catalog. Sorry, I created the Apache Iceberg table in the Snowflake catalog using Snowflake, as you can see there. And the Apache Iceberg table is on the same S3 bucket that I use for AWS, right? So this is why you would need the cross-account capability. I was able to read and write data, of course, using the Snowflake catalog, but I can only read using Spark. Again, that's a limitation of the way that the private preview is implemented. Unfortunately, I was not able to bring in the Apache Iceberg table into the AWS catalog. It was weird because when Snowflake created the metadata that's for the Apache Iceberg on that bucket, the formatting was weird. It just didn't, AWS catalog just refuses to recognize it. It was putting things in the wrong place, right? So this is what I was talking about, standards and kind of like the engines complying to those standards, right? So, and hopefully they'll be able to fix that soon. I did open up a ticket with them, so they said you're gonna take a look at it. All right, so just to summarize, sorry. Yeah. To summarize, I was able to create from AWS, read and write on AWS. You can read using SQL, Snowflake engine on the right-hand side. I was able to create on Snowflake, no problem reading and writing using Snowflake. And I can read with Spark using the same Snowflake catalog, but I can't do anything on the AWS side, right? So other engines like Trino and Dremio, Snowflake said it will come in time, so we'll just have to wait for that one. Now, not everything is rosy in the Apache Iceberg space. There's still a few challenges. Not all SQL engines are created equal. Hence, the support for the Apache Iceberg compliance still varies, and you saw that in the example, right? Not all Iceberg catalog are implemented the same way. Again, it comes down to the compliance to the standard. This was an issue that I ran into when I tried to import the Snowflake created Apache Iceberg into the Glue catalog. The Apache Iceberg versions, even within AWS, vary. That's a pain a bit. Snowflake and AWS, for sure, they have different versions, but within AWS, like EMR is using a different version from Athena, so you got to be careful with that one. So the other thing is you can only read and write from the same place where you created the catalog, if that makes sense. But you saw the arrows that I had before, so hopefully you took a picture of it. Access controls can be implemented by the SQL engine, but that's still varying in implementation, right? So, and then performance-wise, I did see some difference. It wasn't like a huge testing that I did. So because it's private preview, so more to come on that one, I'm sure. So with all of these challenges, what should Maria do? Should she give up and say, the hell with this? I'm not going to do this anymore. No, I would say continue with the Apache Iceberg. She needs to be patient, wait for the Snowflake to GA the support for Iceberg, and hopefully some of the features that they announced today is actually going to be available soon. I would recommend that she implements on the AWS side first, and then try to figure out how to actually synchronize that with the Snowflake and vice versa, right? So the other way, I'm not sure how to do that yet. So maybe that's something that I need to experiment with. So this was the demo that I was supposed to do. So I started working on the script to do the demo, and the Snowflake demo committee said, no, you can't do that because you can't do previews. You can't do demos of private previews. I'm like, all right, but what about screen share? They said, yeah, you could do that. All right, so let's do that. So these are the two Spark configurations. You'll see that the one on the top is the Glue catalog. The one at the bottom is the Snowflake. You can see if you could read this, right? You can see the implementation for the default catalog is the AWS catalog, and Spark catalog is kind of like the higher level one. So that's the abstraction. So, and if you look at the bottom, it's the Snowflake catalog is the implementation of the Spark catalog. The endpoint's a little bit different, right? So the endpoint on the top is the AWS region for S3, as well as the bucket themselves. And at the bottom, it's the JDBC URL endpoint of my Snowflake account. If you're going to do this, don't forget your proxy, because it took me days to figure out that I needed to set my proxy. Trino is very similar, except that they use the Hive catalog for some reason, and the Hive store. I don't know why. So if anybody knows, come see me later. Maybe you could explain to me. But it works. So the underlying idea works. The Snowflake configuration. So for Snowflake, you need to create external volume, storage, integration, and stage. I was told that this might change. Don't know when, how. Again, this is the perils of a private preview. But if you look at the documentation of Snowflake, the Apache Iceberg, it's pretty good. So it explains all of these there. So the volume is where you point the bucket to. That's where I create my Apache Iceberg table. That's the one in the middle picture that I had before. The integration, and that's to create it from Snowflake to the Apache Iceberg, right? The integration and stage is to bring the data in as if they were external tables, right? So what you're seeing here is my Jupyter notebook. I was using Spark, AWS, and Apache Iceberg support in it. I was able to create the database. I was able to create 2 tables using Spark APIs. I was able to use a select statement, SQL syntax, right? So again, that's the Polyglot capability. Using the same Jupyter notebook. Oh, this is the history. So you can see the snapshot IDs. Snapshot IDs are hierarchical. They're like parent-child relationships. So you could go back in time and do time travel. And then you can see some of my queries down here that shows how to query the data using the snapshot ID, using Spark API. Of course, you could do this with a SQL as well. Like this one is in Athena. You use the same snapshot ID. They call it version in Athena. It works the same way. So if you saw the query before, it works as the right counts. And this is the one that actually does the comparison between the same table, different versions of the data. That's when it got updated, right? So Trino, same thing. I just use command line for Trino because I didn't really have a good service for this. But I just took the same query, implemented it here, and it runs fine, right? So now if you jump to the Snowflake, here's where I created the Iceberg table using the external volume I mentioned earlier. Is that right? Yeah. So then I populated it just using this simple import. And as you can see, I was able to query the S&P 500 index. Now in Snowflake, you can import the data that we created in the AWS using the create table statement as well. And you can see here, it's pointing to the stage that I showed in a different screen before. So that's the stage to import the data. And the location of the bucket is there. And then you just need to specify the type as the table type as Iceberg, right? So So this is where, when I did this, the reverse, the metadata stuff was just like not right, or they weren't consistently implemented. So, and then once I actually, imported the data, you can now query the data using the Snowflake engine without having to move the data into Snowflake. And then the nice thing about this, just to complete this, is that you can then actually join the tables that I created in AWS and join it with the Snowflake one, and it works. So it avoids Maria from doing a lot of the ETL and stuff like that. So this is just to show you that you can do the same thing this is the Spark catalog. This is using Spark reading from the Snowflake catalog. So the only thing I was able to do here is read the table that was created in Snowflake catalog. I was not able to join using the other one. So, and don't forget, you need to do that vectorization for some reason. Using Spark instead of the API, you just use the SQL. Yeah, so this ends my presentation. I want to thank everybody for coming. Hope you learned something today and go forth and build your own Polyglot data platform. So thank you.